So here for starters, we're going to draw the angle in standard position for a 175-degree angle. What you do, okay, you set up your XY axis. Once again, we are measuring off the positive side of the x-axis. The origin is going to be the vertex. As you measure off the positive side of the x-axis, if I'm traveling 175 degrees, working my way out this direction, once I hit the y-axis on the positive side, that's going to be 90 degrees, right? If I go all the way to the other side, that'd be 180. So I want to stop just short. If I stop just short, for illustration purposes here, just to get a sense of what an angle in standard position looks like, this would be 175 degrees. Not too complicated, right? Now, other angles we're going to become familiar with here, and we're somewhat familiar with already, having dealt with the unit circle. If I throw some pi stuff at you, at negative 7 pi over 4, let's say, well, how we treat negative 7 pi over 4, we treat it just like we did with the unit circle. We'd be starting on the positive side of the x-axis here. We're traveling in a negative direction. That means we're going to go clockwise. And if it's negative 7 pi over 4, we're going to divide that out like we've always done. Make that negative 1 3/4 if you divide it out. And then if we go halfway around, we know that's negative 1 pi. We still have 3/4 the distance to cover to the other side. That's going to put us somewhere over here in the first quadrant. If I draw my terminal side of the angle, that would be an illustration of negative 7 pi over 4 as an angle in standard position. So how could we make this any more complicated? Well, let's try this. Let's go back to the degree side. Let's do 730 degrees. We're trying to illustrate 730 degrees as an angle in standard position. We highlight the positive side of the x-axis. We recognize we're going in a positive direction. We appreciate that if we go all the way around, how far have we gone? 360. And if we go around again, that's another 360. So that's 720. Haven't got there yet. We still got 10 degrees to go. 10 degrees isn't very large, so if I go up a little ways, draw my terminal side, there's 730 degrees. All right, so if we have to find the radian measure of 140 degrees, we're going to start with our 140 degrees. We're going to multiply that to, based on the conversion we were just talking about, we're going to multiply that to pi over 180. From degrees to radians multiplied by pi over 180. That allows you to keep the pi in the answer, which usually radians measures will have. And if we do some basic fraction calculations here, we're going to have 140 pi over 180, which we need to reduce. If we reduce, you got some 10s that divide out right away. We got 14 over 18. 2 goes into both of those, so we've got 7 pi over 9. 7 pi over 9 would be the radian measure, where if we drew out this angle in standard position, it would be the exact same spot as if we drew out 140 degrees. So literally the flip side, number 5, find the degree measure of 3 pi over 5. Start with 3 pi over 5. multiply by 180 over pi. We're going for a degree measure, so usually we're trying to cancel out the pi's. The pi stays on the bottom. If you multiply that out, and you just multiply straight through without canceling anything, you'd have 3 times 180 on top, which would be 540. Pi would go with that, all over 5 pi, at which point we can cancel out the pi's. You got 540 over 5. Normally it's going to be a fraction you just reduce or divide out. Here it divides out evenly. 540 divided by 5 would be 108 degrees. So again, if we drew out the angle 108 degrees as an angle in standard position, it'd be the same as if we drew out the angle for 3 pi over 5. All right, whenever we're trying to find something that's coterminal and we're talking about a degree measure, coterminal means it shares the same terminal side if the angles are drawn out. So the only way that can happen is if we continue to make entire revolutions to get back to that same side. So with degrees, an entire revolution is going to be 360, right? If I'm trying to find something that's positive, let's take our 215 here. Let's add on 360. And if you add on 360, now let's see here, we get 575, right? 575 degrees would be positive. It would also be coterminal if I drew out the angle with 215. So if you're looking for something positive, it makes sense, keep adding it on, right? If you're looking for something negative, I'll start with your angle measure of 215 again. This time, subtract. Okay, keep subtracting until you get something negative back. As it turns out on this one, we get something negative back right away. That may not always be the case. You might have to do it a couple of times. But if I subtract 360 away, let's see here, we get negative 145, right? So if I drew out that angle of negative 145, it'd be in the same position as 215. They'd be coterminal to one another. All right, so very similar type question here on number 7. We just kind of rearrange the wording a little bit, put some restrictions on where our answer needs to be. Our answer has to be between 0 and 2 pi. But if we're starting off with a radian measure and we're looking for something that's coterminal, you know, like we've done before, might be a good idea to take that radian measure, divide it out, you know, take the pi out of it for just a minute, divide it out, and it becomes what? 3 2/3 if we divide 11/3. So as I make a connection to where I'm trying to get my answer to be between 0 and 2 pi, I'm taking the pi out of it, 0 to 2, 3 2/3 would be larger. So if I want to get back to this little range right here, I need to subtract back to that range. I'm going to take my 11 pi over 3 then. I'm going to subtract. Since we're talking about radian measures, what we always add or subtract with the coterminal stuff is going to be 2 pi, right? 2 pi is 1 revolution all the way around. So subtract 2 pi. Dealing with fractions, got to find a common denominator here. Common denominator is going to be 3. So that's over 3. That's going to be 6, right? We subtract through, we're going to have 5 pi over 3, right? At this point, I do a little check. Take the pi out of it. Take 5 divided by 3. You get 1 2/3, right? Is 1 2/3 between 0 and 2? Sure it is. So 5 pi over 3 would be the answer we're looking for.